Here, once we open, we see that it is some kind of software in the browser, and this is very simple Bayesian network modeling tool, which allows me to draw Bayesian networks and to define parameters and then to do sampling and reasoning by sampling. And I will show you here how it works. In order to explain how it works, I will show you, usually in order to understand how it works, you can use few examples that are built into this tool. In order to call these examples, go to the menu and press Use Toy Network. Here, you can choose few toy networks. Usually, all of them are well known, presented in many books. And we can start from very simple network, basic bronchitis. So here we can see that we have two variables network, smoker and bronchitis. Usually common knowledge will suggest that if you smoke, then there is definitely bigger probability that you will get bronchitis. So this is why we have link from smoker to bronchitis. We can say that smoking causes disease, can cause disease, bronchitis. Okay, once we have finished our network, we need to define parameters for each variable. In order to do it, you press on variable, and here in the right side, you will see parameters for this variable. Because it is very simple binary variable, it means I need to define what is probability, and this variable smoker doesn't depend on any other variable. It means that I need only to define what is probability that some random person will smoke, and here it is 0.3. And by probability definition, then what is that any random person will not smoke? It will be 1 minus 0.3, it means 0.7. Here I can change parameters. For example, I will write 0.2, and immediately it will be recalculated. The opposed reverse event will be calculated immediately for you. So this is how I define parameters for independent variable. Then I go through my graph and choose next variables that are below or are dependent from my variables which I defined above in my graph. We can press another bronchitis variable, and let's look at this table at parameters again. Because bronchitis variable depends on smoker, it means in order to define model parameters, I need to define conditional probability. What is probability? That someone will have bronchitis, true, 1, if he or she is smoking. And here we have 0.2. The reverse event, it's calculated immediately by subtracting from 1 probability, which we just defined. And because it's conditional probability on smoker, I need another set of parameters. What is probability that someone will smoke, someone has bronchitis, if he is not smoking? In this case, we have definition 0.01, and opposite event is calculated automatically. Once I have this simple network, I can do inference by sampling, and I will show you how can we do it in this case. So this is very simple network. It's completely defined. We can see variables, and I expect that you will do something like this later with 6 variables. So how we do inference by sampling? Because it's toy example, so here I can do generate sample from my network. This point, just you press this menu point, sample from network. Let's define that how many samples I want to generate to be generated. So let's say 20. You can try other variants as well. If I already know I have some evidences about my variables values, I can fix these variables values. For example, if I already know that someone who are trying to diagnose is smoking, I can fix it. Yes, he is smoking. I just fix it, and it means it's already smoking. It's not a random variable. It will not be randomly generated. Then press run, and I have randomly generated data from my model. Because I fixed smoker value to 1, we can see that it's repeated everywhere in this data as 1. It's fixed, it's not randomly generated. Then, once I have my data, I can answer by using data analysis any questions I like. For example, what is probability that someone has bronchitis equals to 1 if, because I fix it, he is smoker, so smoking is 1 as well, because we already fixed it. These kind of questions, how I calculate. I use fraction for calculating probabilities because I generated 20 records in my data. So below I write 20 records in my data and then go through all the records where bronchitis is true. So for example, I calculate how many rows in this table we have where bronchitis is 1 true. 1, 2, 3, 4, 5. And here we are. 20% chance that it's empirical evaluation that if someone smokes, then with 20% probability he or she will have bronchitis. This model. I can try to do inference for any other variant in my network. For example, again, I can regenerate. Let's say I need 10 rows. I will reduce number of rows. But in this case, I will not fix any variable. And I can run, then I can ask other questions. For example, because I haven't fixed it, don't have any evidence. So I can ask questions in the form of unconditional probabilities. For example, what is probability that someone will smoke and he or she will have bronchitis? B is equal 1. So again, here, my fraction in nominator, I have 10 because 10 records I generated. And now I go through all the records where bronchitis and smoking is true. So which one? This one is true and there is no other one. So I write 1. And it means with 10% chance that in my model is telling that in my domain, there is 10% chance that any random person will smoke and will have bronchitis. So this is very simple network which you need to analyze to play with in order to understand how it works, how we do this inference. Once we understood this one, you can choose more complex examples. For example, one which is in our book, in our course we analyzed burglary, and here we have 5 variables. We can see that there is dependencies, the same dependencies in these examples as in the book. Then for each variable, we need to define parameters. In this case, I put on my variable, and here we can see that these parameters. For example, what is probability that burglary will be true? Someone will break in my house. It is parameter 0.001, and opposite event will be calculated automatically. The same, I can go to another variable. Then I go to the dependent variable for each burglary and earthquake possible values. For example, what is probability that there will be alarm if there is no burglary but there is earthquake, and this is parameter is defined by some expert or by some data analysis. And we go through all the variables in our network and define parameters. Once we finish definition of our parameters, we can do sampling and then do inference. So once I have this model defined, I can do sampling again, for example, run 20 records. If I have some evidence, I can fix some variables. For example, Mary hasn't called, alarm is triggered, and I can run through all the data. My fixed variables, which represents evidence in my query, it is alarm is true, it's everywhere 1, and Mary doesn't call, everywhere is 0 because I fixed it. And other rows are generated randomly using parameters which I defined in my model. And then I can again ask any questions to my model and do some kind of inference. Once you understood how it works, you need to draw your own network, and you can do this by simply defining variables, in our case 6 variables, and drawing dependencies and then defining parameters, and then generating samples and do some inference. In order to put variables, you simply double click on the canvas and you have new variable. You can change name of variable whatever you like. You can define parameters of this variable, but before defining parameters, usually you need to draw dependencies. In order to draw dependencies, You choose variable and drag your mouse point from this variable to any variable which you think is dependent on your variable. For example, this one and this I can draw again like this. And by this, I'm defining dependencies in my network. Once I finished to draw dependencies, then I define parameters, because you will see parameters table will change. If you change drawing immediately, for example, if I have earthquake, it depends only one parameter, one row in parameter table. But if I just draw dependency to earthquake, for example, we'll draw this one and this one, then I expect much more complex parameter table for each of my variables that are parents to my variables. I need to define parameters in this case just conditional probabilities. So that's it.